welcome back for a lecture series on remote sensing. In this lecture, we would like to discuss about the platforms. Platforms carries a meaning, inbuilt meaning, that where we are going to keep our device to record the information. In satellite remote sensing, we have already discussed about the history that how it was started. People have explored this technology, how it is coming to an end. And it was initially used by balloon, by aircraft, by subsequently they found that okay, it's having a lot of applications with respect to military is concerned. People have scientists joined together, and then that they thought of bringing space technology, and now we have technology. So platform is very important one for any remote sensing person to understand which platform it is required for him to take the information. Now plenty of other recent technology like platforms came into the picture, like UAV, unmanned aerial vehicle. Again, it plays a very important role in remote sensing. You don't need to wait for a satellite to come to your place and then take the information, get the permission, and then proceed by using drone data. We will see the different platforms and its application and not application and its uses for the remote sensing scientist who is working with the satellite data for different disciplines. And this is one small picture which I have taken from the internet sources, courtesy for them to provide such a good thing. And you see, you have stations up to 150 meter from the ground. You use your device. You stand and take photograph, or you just maybe 150 meter from here, and then of course I have some 2-3 images, so that it will be easy for us to understand what is the different platform on which we are now going to work on. So this is the first one, 150 meter, whatever the instrument you keep, and then take the information as a photograph by using either the camera or any devices. That is called ground based remote sensing. From 150 you have you go to up to this place, and nearly for about 12 kilometer, or this one up to this place where you have aeritic zone. So this is called airborne platform. Here now you are going to use the airborne devices like aerial television, aerial photography, airborne synthetic aperture radar. You can also use drone. So drone is the crossing border between these two. Of course, it will fly over this or fly over here. Now this is the and above which in the space vacuum place you keep your device, that's called satellite borne. And we are now going to see some because few of the photographs are really understandable easily. Once if you look at and then discuss, it will be easy for us to understand. Satellite operational synthetic aperture radar, that's nearly 900, and the space shuttle it travels. That this is the space shuttle. You can use this sort of and this is little the same figure in different formations, like aircraft, aerial televisions up to 3 kilometer, up to 3.5 kilometer aerial photography, up to 900 kilometer satellite, and up to 575 space shuttle, and up to 12 kilometers, from 10 to 12 kilometers is airborne synthetic. So where you are going to keep your device and take the information, that is the interest of the present discussion. And you can use many platform, and how you are going to use unmanned aerial vehicle, UAV based remote sensing height. You can go from 100 meter to 3 kilometers height. You can use the drone technology. Now drone is very famous for all applications, and because the cost is cheap, that you can send your instrument and then take the interest of your area. And the aircraft we can use to scan the height varies up to 30 kilometers by using aircraft. Coverage may be 10 to 100 square kilometer, and satellite also you can use coverage in terms of 185 square kilometer, 185 kilometer. The height may be of around 900 kilometer from the earth. That is called sun synchronous satellite. And the platforms initially people have used balloon. They have kept that the camera here, and the camera balloon will move wherever the balloon move. Balloon is taking photograph continuously, but balloon is controlled by, you can control, but you cannot 100% control. It is also controlled by the amount of wind which is there in the atmosphere. It is also initial tool people used. And this is the another very interesting this thing. And you see, you have a drone, you have aircraft, you have if the height increases, the figure says that the resolution of spatial coverage is also increases. You can have a better, bigger view of using your device. So that is the rule of platform. So what platform you are going to use, either the ground based, near ground based, airborne or spaceborne platform. And this is categorized into three. A man who can stand even by using a camera, he can take photograph. That is called terrestrial photograph or ground based photograph. Normally we tell that it is a terrestrial photograph for having a look at a hill or a valley and then take information. That is called terrestrial photograph. And then rise, you can also rise your platform and then stand, sit over that and then take the information. And in the air, you can use a balloon, you can use a space shuttle, you can use a different balloon type, and you can also use helicopter or you can use your aircraft. So aeroplane, helicopter, hot air balloon, airship, tethered balloon also. You can even use keep your device by using a tethered balloon. People have experience. That is the history and there is a development. Why do they use this? Because it gives a lot of information immediately. One can take any decision if any threat is there or any disaster is there. You know that especially wherever the disaster comes, you know your UAV now started playing a very, very important role. And space satellite is being used and shuttle is also used for taking these images. This is the shuttle, this is the satellite. So okay, it is categorized based on the place where you are going to keep your device. That is called the platform. And this is the one image. It's being taken from the standard textbook of remote sensing. Normally we have represented this like this. You know, low altitude data. You can use ground observation, low altitude data, high altitude aircraft, and then satellite. And this is a ground level remote sensing, aerial remote sensing, and satellite spaceborne remote sensing. So this is what we have seen, you know, from a handheld camera, target camera, and you can use a balloon, helicopter camera is fitted here. That is aircraft balloon is fitted. I mean, your camera is fitted here. Airborne high altitude, medium altitude, and MSS in the satellite is being kept here. What is the platform? What is the advantage and disadvantage? This requires a little bit of discussion. The reason that you have whatever the work you do, you have both end, ADV and DADV. We will have to see how DADV has to be corrected. You cannot overcome. You can correct and then you can use. You know that everywhere it is there. You do whatever the work you do. ADV and DAV, it is a component, inbuilt component. You see, satellite, if you use low cost over larger area, of course it is true. If you are going to work with a larger area, now it's not. I think many disadvantage become advantage nowadays. Many disadvantage is advantage because of the advent of the technology. Now even the data up to 10 meter, it's free of cost. 30 meter initially they have given. Now Sentinel came forward to give data 10 meters. I think this slide we don't need to discuss much. The reason is it's a very old syllabus. This one. Anyway, let us see. Sensor are consistent in satellite. You cannot change. This is see position and time accurate will be there. No mobilization. You don't need to mobilize your equipment. It is automatic. And the system acquisition provides data, legacy, rich time series, thermal and hyperspectral. You see thermal and hyperspectral sensors available. A wide range of radar data is available for the end users. Captures the broad pictures, the broad pictures. Atmosphere and weather can be measured by using satellite. Of course, you cannot do manually. Gravity anomalies can be measured. What is the limitation? Limited to 1.2 meter spatial resolution. That is true, but you know some costlier data product, high resolution data product like WorldView 2, it is being now used. WorldView 2, WorldView 3. It is not of much cost, but it is also little bit cost. That is there. It can be affected by closed. It can be affected by closed and atmospheric condition. Capture time restricted to fixed satellite. This is there. Failure of satellite also will cause problem for us, and this can be rectified by the government. It is not by the individual to do everything. And similarly for manned aerial, normally we are not using, but UAV, it is a recent technology of this remote sensing platform. Easy mobilization at any place. Cost is very less. It can be highly accurate. Nowadays 3D you can generate by using this. Allow almost instant feedback. Can provide oblique imagery enhanced 3D modeling. That's what I said. Typically more expensive initially, but now it is not expensive. It is cutting edge technology. Recently it came, and then one has to use the when you are working with remote sensing. Now this is mandatory for us to know, for us to understand, for us to learn, for us to work with the unmanned aerial photography. No advantage and disadvantage it is there. It's not affecting the individual user, but one has to know about this. The platforms, there are two, there are three, they said, but broadly they have classified for remote sensing too. The selection of platform depends on the type of altitude you are going to fix. Atmospheric condition is very important for us to look at any platform if you keep your device. Satellite or radiometric or handheld or aerial or crane car, whatever you use, but atmosphere plays a major role to control, to take the information, to capture the information about the different object or the earth surface. This is one table shows that what is the distance. Normally we use for ground truths up to 30 meter, crane car up to 5 to 550 meter, cable up to from 10 to 40 meter. And these are all the observation, where the ground truth study, close range survey, aerial investigation, archaeological investigation, balloon from 100 meter to 100 kilometer for various investigation, 500 to 8000 meter low fly, and 10 to 12 kilometer high fly plane, and 240 350 shuttle, and low earth orbit 450,000, and geostationary is around 36,000 kilometers from the ground. And various uses, this is very important table. One, we expect from all the students what is the distance of various platforms covers. For aero survey, for reconnaissance study high altitude plane, space experiment space shuttle, regular earth observation by low orbit, fixed point observation by fixed point like telecommunication and other studies by geostationary. Now emerging platform, UAV is the emerging platform. Normally now it comes around 2 lakhs. Now it's very costly. Initially it was 20 lakh. Now it is very less. But people have started utilizing this. Once if you introduce, only few percent will use for good, and many people will use this technology. Will give trouble to the common end user or the people or the society. So that the government came forward to put a lot of regulations. We will see in the next slide. So unmanned aerial system, unmanned aerial vehicle, both are same. This is remotely piloted aerial system. It's nobody is there inside. It rather you can call it. It is also a robot. It is also the other name for this. It is a drone. And these are all the different terminology used. And what is the component that you see? You can use some camera. You can use a small device. You can use my MSS also in the drone, depending upon the weight it can carry and what time it is going to, and what height it will travel, and up to what time it will be there. The unmanned aircraft control station, from the human communication, it is through your that signals and payload mission planning. It is required for one to use this. Government used drones for tiger census catch, but mostly in tiger census in Uttarakhand 2013, Jammu 2014 floods. They have extensively used this. Hunting ops for moas in Chhattisgarh forest also they have used this. Maintaining law and order during any of processions. Allahabad Kumbh Mela in 2003 also they have used. Expected civilian usage, local area mapping you can use. Pesticide control or fertilizers spray you can use. All kind of surveillance you can use. Detailed visual media coverage you can use. Transporting human organs to the hospitals you can use. Logistic home delivery of items to the customer also, if it is so costly, you can use. But what is the law given by India? It is that in October 2014, people that after inventing this, many of them have started utilizing this and then troubling others. So drones in India have been banned since 2014. Regardless in their use, India is currently in the process of creating expensive regulation covering the use of drone in India. Until regulations are created, civil operations of drone will require approval of DGCA, MOD, MOH, and other concerned security agencies within India. Otherwise, you should not use. It is banned. What is the advantage? It is more flexible, cheaper than satellite airborne system. Major focus on local applications. Immediately you can use. Save life, support law enforcement. Mainly this is being used for disaster management, like saving life, supporting law enforcement, safe infrastructure maintenance, streamline agriculture management, and media access to hard to reach places. Yes, this is being a lot of uses. In spaceborne remote sensing, sensors are mounted on spacecraft. The advantages because of larger coverage, rapid data, in no time it takes information, frequent and repetitive coverage, no permission to get the data, quantitative measurement, and simulated computerized processing analysis. These are all the things in the what is that in the platform along with the sensor is concerned. What is the disadvantage? High cost of satellite and launch system, high cost of data reception infrastructure, planning, building, testing, launching. At any point, possibilities of failure because of complex subject. That because it involves mathematics, it involves signal physics, it involves knowledge of geology for people those who see platform. Not only that, launching and then keeping device continuously to rotate and then maintaining from the ground. It is there. We will see geosynchronous and sun synchronous in the orbit studies and polar synchronous. And this is the ocean sat, how it takes the information for the whole area by keeping your device near 1,000 kilometers from the ground. And IRS 1C 1D, it takes the information in the orbit, the sun synchronous platform, and it gives the information to the ground station. Do you see that? This is commercial communication satellites, geosynchronous satellite, which was kept 36,000 kilometer away. It is in the equator. You see number of satellites revolving. It is more. Boeing 17, others 222, nearly 300 satellites. It is there by the orbit. So with this, the place of platforms kept in the satellite from ground to air space has come to an end. Thank you very much.